Good.
Good. All right, so what do we have today?
More algebra.
Okay. Do you have anything new to send me, or it seems like...
I have, yeah.
Okay, go ahead and send it. I was sitting there thinking that I think you sent me 3 documents last time, and we only covered 1 or even 2 of them.
Well, I just sent you one, I think.
Okay. There it is. 2 documents. Start with the one on the left.
Okay, yeah.
I mean, do you have a preference?
The one on the right, I was confused about a few problems on the bottom.
Okay, let's look at that one first then. I'm still having a little bit of trouble with my new operating system, but let's see if I can figure it out. Snap left, snap right. All right, where would you like to start?
The bottom, maybe Q.
Factor the polynomials completely. You want me to check your work here? Looks like you've done a lot of these.
Yeah, but the bottom ones I wasn't so sure how to do.
Okay, so which one? First of all, are you sure that you did these correctly, or you want me to look at them as we go through? Or we can just start with J, if you're comfortable what you've done.
Yeah.
Well, let's go back to A. I see a mistake here.
All right.
Okay. You factored out an xy, which is correct. But when you do this, always make sure that when you multiply these back together again, you get what you started with. And you'll notice that if you multiply xy times this term here, you get x squared y squared. You don't get y cubed.
Okay.
So that needs to be squared, y squared. Then it would be exactly equal to what you started with. Second step, what's the greatest common factor of that? Whether that's y or y squared, what's the greatest common factor of what's in the parentheses?
6.
Okay, so we should take a 6 out, not a 3. And when you multiply these things back together again, 3 times 3 is 9. So that tells you made a mistake right there. So that should be a 6, that should be a 1, and that should be a 4. Okay?
Mm-hmm.
This one, B looks correct. C, we factor out a 2, and then we factor it into y minus 11. Y, that looks correct. Let's look at D. We factor out an x, and then we factor that. That looks correct. E. Notice that your answer for E does not produce 3x squared as a first term.
Okay.
Has to. Otherwise you did it wrong. Let's play with this one. These are harder because the coefficient is not 1. But our job is still the same. Let's split up the 3x squared. What does it have to be here and here? There's only one choice.
3.
Well, it's got to be 3x and x. In other words, that's the only way to factor that first term.
Okay.
So that's the way it has to be. Now, it could be x here and 3x over here, but that's not important. What do the signs have to be? The same or opposite?
Same.
No. You cannot produce a -2 if I have a negative times a negative or a positive times a positive. Remember, this term here is always the result of multiplying that times that with the sum.
Okay.
So we know the signs have to be opposite.
All right.
Now, because this is 3x and this is x, it could be plus minus, but it could also be minus plus, and they would be different. They're only, in other words, the only time you can get away with just putting plus minus is if the coefficient on the x term is the same.
Okay.
Now, what are factors of 2?
2, 4, 6.
No, just 2 and 1. When I
Okay.
say what are factors of 2, I mean what two numbers multiply together to give you 2.
Okay.
That's 2 and 1. That's it. So now it's a trial and error process. Let's try 2 and 1 right there. What is the middle term? In other words, what you have to be able to do is always check your middle term here. We know the first term is correct. We know this term is correct. The term we're trying to get correct is this term right here.
Okay.
Well, with this choice, and this is a trial and error, what do I get? I get, in other words, you multiply the insides and the outsides. That's what produces the middle term. Well, the inside gives you plus 2x. The outside gives you minus 3x. Add those together, that would be the middle term.
Okay.
Okay, and that is not our middle term. So that clearly is not correct. So we'll erase that.
They have to both be positive
What's
to get
that?
5. They have to both be positive to get 5.
No, they don't. If I have that and that, notice that the 2 is multiplying 3x, and the 1 is multiplying x.
Okay, I get it now.
That produces minus 1x. That produces plus 6x. That gives you that middle term. That means that's the right choice. So that's the way that is factored.
All right.
Now back to our problem. And that's the final answer, actually. What I've written here, not what you've written. Okay, let's look at the next one. I'm going to write it out. 4y squared plus 4y minus 3. Well, let's see if we can factor it. Break up the 4y squared. What's the most likely way that we should break it up? What would multiply together to give you 4y squared?
2y.
That's one choice. 2y and 2y. Another choice would be 4y and 1y. The only rule is you have to split the variable. But the number, you have a lot of choices. So we're going to try, again, this is trial and error. Okay?
Okay.
We're going to see if this works. What do the signs have to be?
What
Both?
Negative and negative or positive and positive?
No, you could not produce that number with either of those. If I had positive, positive, then my constant would have to be positive. Remember, you get this constant by the last step of FOIL, multiplying that by that. Well, you can't produce a negative 3 unless the signs are opposite. So it can't be positive, positive. It can't be negative, negative. It has to be positive and negative. Now, in this case, I can get by with just writing positive, negative because my coefficients are the same. In other words, negative, positive is going to be the same as positive, negative. It won't matter. So, what are my choices for factors of 3?
3 and 1.
Okay. Well, let's try 3 there and 1 there. Nah, I'm sorry. Let's try it the other way around. Let's try 1 here and 3 there. And at this point, it's just a guess. Okay? In other words, I'm trying all combinations where there's only 2 combinations. It's either 1 there and 3 there, or 3 here and 1 there. Well, what would this produce as a middle term?
What
do you get when you
multiply
1 times 2y?
2y.
Plus, the sign is very important. What do you get when you multiply minus 3 times 2y?
Negative 6y.
Add them together,
Negative 4y.
and that is not our middle term, but it's the right number, just the wrong sign. Well, as all that tells us is that we just have to switch them. And now I'm going to get plus 6y there, negative 2y there, and I'm going to end up with plus 4y as my middle term.
Okay.
So factoring is really largely, I mean, you can talk about the California method and the diamond method and all of those, but you got to realize that it's a process of trial and error, no matter which method you use, even if you use the diamond or the California method. But you really don't need to memorize any of those methods. You just have to know how to apply trial and error. Now, let's look at this next one. So you factored out a 2. Okay, so we ended up with 2 times 4x squared minus 5x minus 6. Now we have to try to factor that. And don't forget the 2. A lot of times people will leave that 2 behind and not put it in their final answer. Where am I going to start with trying to factor that quadratic right there?
2x on each side.
It's a good starting spot. That isn't necessarily the answer. Could, like I said, it could be 4x and x. But I always tell students to start with the 2 factors that are closest together. 2 is closer to 2 than 4 is to 1. What do the signs have to be?
Wait, what if 4x was cubed instead of squared? How would you do that?
You wouldn't do it this way. This is only done for quadratics, not cubics. Cubics are a whole new ball game.
Alright.
Unless you can reduce the cubic to a quadratic. If you'll notice this v down here, I can factor, no, that's totally different. That is not going to be worth our time to look at. Notice m. I can take an x out. And once I've done that, I'm left with a quadratic.
Okay.
So the only thing you really want to care about, same with h. I can take an x out and I'm left with a quadratic. They have not taught you how to factor cubics, but they have taught you how to factor quadratics. That's what we want to master. You could go
Well, we
a long
got taught a whole bunch
way
of...
without ever knowing how to factor cubics, but you've got to know how to factor quadratics.
Well, we got taught like 20 different ways to solve the same 3 equations over and over again today. Now we have a test on it on Friday.
Okay.
Which
well, the best I can do is I'm really good at factoring. Okay? So the best I can do is teach you how I do it.
Okay.
And that's what I'm trying to do here, is
to
teach you how to factor that quadratic. And I always start with the factors that are closest together, and then I figure out what both signs are. Well, what do both signs have to be? I don't figure out one sign, I figure out both of them at the same time, because there's only one way to produce a minus 6. What do the signs have to be?
Different.
Exactly. One has to be plus, one has to be minus. Now I'm looking at factors of 6. That's step 3. Well, let's list factors of 6. There's one of them. What's another one?
6, 1, 3, 2.
That's it. Which ones am I going to try? That one, because they're closest together. That's not necessarily the answer, but that's where I'm going to start.
All right.
Now, if it doesn't really matter where you start, if I write 3 and 2, does that produce the correct middle term?
Yes.
No, it doesn't.
Wait.
That's 6x. That's minus 4x. So that produces a middle term of 2x. This is a critical step here. It's what I call my double smiley face step. Because the only term that is in doubt is the middle term. In other words, what we have to do is play around with all combinations so that we eventually produce the middle term. Well, 3 and 2 doesn't do it. Let's switch them. Let's put the 2 there and the 3 here. Let's see if that does it. Well, I just did that. Switching them gives you the same number but opposite sign. So I'm still going to get a 2x, but it's a positive 2x. So that doesn't work. So back to the drawing board. I still know the signs have to be opposite. Okay? And I can kind of tell that 6 and 1 are not going to work because the 6 is going to have to multiply a 2x regardless. That gives you 12x. You're never getting back to minus 5x. Okay?
Yeah.
So now it's really back to the drawing board. In other words, I got to go back and try 4 and 1. 4 and 1x, like that.
Okay.
Now, because these coefficients are different, I also have to differentiate between plus and minus. So I'm going to list both. Plus, minus, minus, plus. It's going to either be
For
plus,
this, are
minus,
you
or
using
minus.
the California method?
I'm sorry, what?
For this, right now, we're using the California method right now.
Okay. I can't really help you with the California method a lot. I've never used it. I know what it is. I'd have to actually look it up to review it. So the only thing I can help you with is the way I best know how to factor. So I hate to say that because you're not the first student I've run into like that half understands the California method, but they don't fully understand it. Well, I hate the California method. I think it sucks. So I don't even attempt to explain it with the California method. I use the trial and error method, which is what I'm using right here.
All right.
Okay? I'm still going to try the factors 2 and 3 for factors of 6. And I can kind of see that if I use 3 here and 2 there, what's my middle term?
3x.
Nope.
And negative 8x.
Add those together.
You get negative 5x.
That's the answer. We found our middle term. So now just erase everything that we don't want anymore. I don't need that, I don't need that, I don't need that, and I don't need that. The answer is 2 times 4x plus 3 times x minus 2. If you carry out that multiplication, you will get what you started with, which is always the key. Now, let me make clear here what this means. I didn't want to. That's x, 4x plus 3, x minus 2. You'll notice that if you FOIL those two together, you get this. And that's the key, is always be able to reproduce the original.
All right.
And it's a trial and error method whether you use the California method or not. The California method really doesn't do anything different. I mean, it sets it up like that, and you have to figure out that and that and that and that. And it's, like I said, it's more confusing than helpful as far as I'm concerned. But if you use my method, you can really never go wrong. It may take you a few attempts at doing it, but you're going to get the answer eventually.
When do you use the quadratic formula?
If this cannot be factored. In other words, if this was a 7 instead of a 6, then I wouldn't be able to factor it. And if I can't factor it, then x is always equal to minus b plus or minus b squared minus 4ac all over 2a. With this being a, this being b, and, that being b, and that being c.
Okay.
Just plug them in. And
when do you know when you can't
there's
factor
always
it?
2 answers to quadratics. Well, those are the 2 right there. One's plus,
Okay.
one's minus. Now, it's unlikely that any of these problems are going to require you to use the quadratic formula. Just looking at them, I can tell that they're not. Okay? So I don't think you have to worry about the quadratic formula. What you have to worry about is how to factor these. There's no getting around factoring. It's a lot of students have troubles with it, and I struggle with this idiotic California method, but I know how to factor. And so I think the best way for me to teach kids how to factor is my way. Call it the Dave Cowan method. But it differs from the California method. Now, this is a cubic, but it's not really. We don't have to know how to factor cubics, because what's the greatest common factor here?
X.
So if I take an x out, I'm left with a quadratic. And quadratics is what this whole page is about, factoring quadratics. So, let's go to work on this quadratic. There's no other greatest common factors I can remove. 31 is a prime number. So how am I going to split up the 10x squared?
And you could go 5 and 2.
5x and 2x. The x you cannot forget. Okay? And that's really the only other choice is 10 and 1. But I'm always going to start with the factors that are closest together. Now, what are my signs given that I'm looking at a plus 15?
Negative and negative or positive and positive.
Correct. They have to be the same. That's the only way I could ever produce a plus 15. To figure out whether it's negative, negative, look at the sign on the middle term. That's negative. Well, that means they both have to be negative.
Okay.
Okay? If that middle term was positive, then it would be plus plus. Now, factors of 15. 15 and 1, and what else?
3 and 5.
That's it. Okay? So, it's pretty random at this state. Let's just try the two closest ones. Does that produce the middle term?
Yes.
Yes. We hit it on the first trial. If I had started with minus 5, minus 3, it would have been no, and then I would have switched the numbers. But we got lucky, and that does produce minus 31x as a middle term, and that's the key. You don't need to check this first term, and you don't need to check this term. The way we did our factoring is we know those are correct, but that middle term is what we're trying to find with our choices on how to factor, and we got it. So that one's pretty easy. There's your answer.
Okay.
Okay. You can see that my method works pretty good. You just have to follow a methodology. In other words, you just follow my method. Nothing else do you have to worry about. It's 3:30, Mark, and I gotta go. I got a 3:30 a client. So I'll talk to you tomorrow.
Okay.
All right.
Sounds good.
Bye-bye. And I'll just keep this page. We can finish going over this page if you want.
Okay, cool.
All right.